So Deepak, we're going to get started here. We're going to do a introduction to Grasshopper over the next 2 hours, where we're just going to see why we're using the software, what it could be good for, and just start to understand a few basic ways to construct logic in Grasshopper. Okay. So if you have any questions, please just write up on the chat. If you need me to slow down, go faster, if you're bored to death, just let me know. Hope not to bore you. If you can hear me okay, let me know. Yes, anything else, just write it up in the chat, and we'll make sure to stay on it. Okay. So, okay, good. So really, what I would normally do under these situations is to give a nice overview of Rhino, because maybe some of us haven't even used Rhino. But more and more, I find that if you've come from already you're a second, third, fourth year architecture student, you've probably already gone through using various CAD softwares, AutoCAD, Vectorworks, ArchiCAD, etc. So the topological topics that are key to understanding Rhino are fairly well ingrained somehow, and we can kind of move directly into Grasshopper. I'm always a little bit wary about this, but we'll check it out, see how it goes, and if we have any questions along the way, we can address those questions. The main thing is that if you haven't used Rhino, there are always at minimum 3 ways to do anything. There's the command line. So if you're used to AutoCAD command line, you can always type the commands. A lot of the commands are almost exactly the same as what you would find in AutoCAD. But you also have a series of buttons. The buttons actually have the commands underneath them. And of course, you have the menu, which I rarely use, but everything is also here in the menu. It's weird though, because just the way that I learned and the way I use it, there are some things that I have no idea where they are in the buttons, but I know where they are in the menus. There are some things that I know in command line, but I don't know where they are anywhere else. So it's just kind of a mixed bag. Why we use Rhino? Well, Grasshopper is quite a big reason for it, but another reason is that it's actually quite compatible with many file formats. Rhino was initially a plugin for AutoCAD to translate files before it was its own CAD program. So it has this kind of background of being really compatible with many types of software and CAD types. And also it's a great, let's say, it has a great support system. So it's quite a small company compared to something like Autodesk. It's about 80 employees worldwide. But and if any question you have, the technical support is actually fantastic. And especially if you're developing custom tools, it's even you even get right to the programmers, and they help you quite a lot. So those are just a few reasons to use Rhino. And Rhino in the last 10 years has kind of architecture has started to use it a lot. But before that, it's really mainly been used for jewelry, for boat design, for shoe design, these kinds of things. So more in that as a kind of an industrial designer, sort of Swiss Army knife. Now, a really nice thing about Rhino is that it has a really accessible scripting interface called Rhino Script. And then about 5 years ago, they introduced something called Grasshopper. Okay. And hopefully Grasshopper opens here. Grasshopper is developed by one person. This person's name is David Rutten. Okay. David was a person that if you were scripting or Rhino scripting about, I don't know, 7 years ago or so, it was basically the reference. I mean, the only person that was also connected with architecture that you could see doing some really interesting stuff. And he would always be on the forums, asking questions to the developers, and the developers were like, who is this guy? These are really relevant questions, and would be really nice to have him as part of the team, and well, eventually become part of the team. Over his Christmas vacation in I think 2007, he just decided to develop this kind of thing that he had in mind without telling anybody, without explaining it to anybody. And sometime in January of 2008 or so, eventually showed it to some people, to Bob McNeil, people at McNeil who make Rhino, and they saw some really interesting potentials for it. But he kind of kept it secret because he didn't want his idea to be, let's say, muddled with other hands. And so today we have this graphical logic modeler. I guess you could describe it in many different ways, which is Grasshopper. So let me first explain a little bit about why we would want to use Grasshopper in such an environment. Okay, let's take an example of a loft in Rhino. Okay, if you use 3D Studio or Maya or these kinds of tools, your operations are already associative. You kind of don't even have to think about it. Okay, so when you make a loft from curves, the resulting surface is probably already connected to the underlying curve. So you move the curves, the surface updates without you having to do much. Maya has something called the hypergraph, which is the, let's say, logic tree that is generated from your actions, but you can't really do much in this hypergraph. The hypergraph shows you how your actions are connected, but you can't really get into it. 3D Studio has the modifier stack. You take an object, you add modifiers, and then you have kind of like, let's say, layers that you can go back and start to mess around with things in there. And there you can start to do some things. There's another software called Generative Components, which was sort of around the same time, maybe a few years earlier than Grasshopper. And Generative Components is sort of a mix between the hypergraph and the modifier stack, in that you have what are called transactions. So kind of objects that, again, you sort of layer on top of each other, and it generates this descriptive tree of your operations. So let's take this idea that I'm talking about here in Rhino, okay? Let's draw some curves. We're going to copy them, and then we're going to make a loft from them, okay? Very simple operations. The curve tool I'm going to use is this control point curve, okay? So I'm going to click control point curve, and here in the front view, I'm going to click 4 times. So 1, 2, 3, and 4, and then press enter. Okay, something like this. Again, over here, control point curve, 1, 2, 3, 4. Yeah, everybody have something like this? Yeah, just 4 points. If you're just starting to use Rhino, you might have some other, what we call drafting tools turned on. So maybe some like ortho snaps and things like this that might force you to draw things in certain orientations. You can press Shift to get these things to not snap to those orientations. If you press enter, it'll finish the command. Okay. In Rhino, enter, spacebar, and right click are the same thing. It will end the command or repeat the command, just like in AutoCAD. You press the command. If I press the spacebar again now, it'll repeat the command for the curve. Okay. Notice that in the command line, you're getting all the information of what you're doing. Okay. So as I click the icon here on the command line, it says underscore curve. Okay. And it has this underscore because you could have Rhino in different languages. So I have it in English, so I don't have to do this. But if you have Rhino in, let's say, Chinese or something, if you do this underscore first, it'll force the English version of the command name. Okay. I recommend people to install Rhino in English because, well, McNeil's an American company. The translations between English and other things are really, they're fine, but they're just I don't know. They're easier understood in English, in my opinion, obviously, because English is the language that I use technically. But anyways, I digress. So this is also the nice thing is that if you're starting to learn Rhino and you're kind of going around the buttons in the menu, eventually the command line just shows you what that command would be. So it allows you to learn a little bit how to be faster by eventually typing it into the command line. So again, to end the command, we press enter, we right click, or we press spacebar. To repeat the command, we do the same thing. Okay, spacebar, right click, or enter. Okay? So right now I just did the curve command. If I press spacebar, it's already remembered that I have the curve command, and it'll do it again. There's a few commands that it doesn't repeat, like delete and a few other things, but most of the commands it'll repeat. Just a few other things, interface-wise. If we're in perspective view, the right click allows you to orbit. Right click and control allows you to zoom. Right click and shift allows you to pan. You can also do these things with these buttons here in the command line. Sorry, in the icon, the pan, the rotate, view, or orbit, and the zoom. In the orthographic views, you can pan with right click and zoom with right click and control. Obviously, you can zoom in and out with the scroll wheel. Okay, this is the same as many other CAD programs. So if there's anything strange that isn't happening, just let me know. But by now, we should all have this curve. Yeah? Okay. So because I've drawn this curve in the front viewport, if I look at it in perspective, we see that it's kind of upright. Okay. It's drawn onto this construction plane, X, Z. In the perspective view, if I would have drawn that there, it would have forced my curve to be in the X, Y construction plane. Okay, same as in top view. But because I drew it in the front viewport, it's upright like this. So what I'm going to do is I'm going to copy this several times. Okay. So to copy, you could guess the command in the command line we put is copy, and you'd be correct. But just to be a little bit thorough, the icon for copying is down here. Okay. So just under this T, there's the copy objects in place. If you click it, you see yes, the command is copied. So it's going to ask you here, where do you want to copy it from? So it's going to ask you for a reference point where it's going to start to copy the object from. And you can click freely anywhere, or you could enter a specific coordinate. For now, I'm not going to do this so rigorously, so I'm just going to click somewhere. Let's click. And you'll see that now in the command line it says, where do you want to copy it to? And you see that as you move the mouse around, the curve is kind of coming along for the ride. So I'm going to copy this in the Y direction, and copy again in the Y direction. When I have two new copies, I'm going to press enter to finish the command. Okay, let's try that again. I'm going to select the curve. I'm going to say copy from anywhere, and I'm just going to copy it along the Y axis 2 times and press enter to finish it. Mehran and Dory, if you can kind of come around and see what's happening with the folks. Again. No.
I kept waking up all night. There were mosquitoes in the room. I don't know what to do. So I kept fighting myself, but then it was really fun. Woke up at like 3 and 5. Yeah.
Of course, for the people who are just joining us learning Rhino, we've just very freely copied these objects without any coordinates. I mean, the proper thing to do would be to introduce coordinates so the copies are moved to the exact positions we want, but I'm trying to illustrate a different point about how Rhino works, okay, or how it doesn't work, I guess, in this case. So here we have curves, and besides this point that I want to make about the way that Rhino geometry works, I also want you to start thinking not so much in geometry, but in objects or pieces of information. Okay, think of this curve as a piece of information. Okay, that's made up of other elements. Okay, eventually the surface we're going to create is going to be a piece of information made up of these curves. These curves are made up of other points. Those points are made up of XYZ coordinates. Those XYZ coordinates are numbers. Okay, so there's a whole topological gradient between the number to the surface. Okay, and I want you always to have that in mind, because when we get into Grasshopper, it's going to be much more thinking in those terms, kind of all the components of a piece of geometry, rather than this is a curve. The curve I can move around its control points. Okay, you're going to have to much more think about these elements as pieces of data. Okay, much like, well, and this is better probably illustrated in when we're into Grasshopper, but much like a word can be thought of as a piece of information. Okay, that word is made up of characters. Okay, individual characters that compose a word. Then a sentence is made up of other words. So there's kind of this hierarchy of information that eventually allows us to compose more complex objects from very simple elements. Okay, that's a basic thing that eventually we'll kind of construct and deconstruct in Grasshopper. Okay, so here we have these three curves. If you want to edit these three curves, just to make our transition, our loft a little bit more interesting, maybe select the middle curve, and now we're going to edit its control points. Okay, we created the first curve from a series of 4 control points in our case. So all of these curves are just exact copies, and they have this underlying structure that we can edit. Okay, to edit the control points, we can select the curve, just click on it, and over here we have this tool point on, which if you have the curve selected and you turn and you click that, you now should see these 4 control points that I originally drew in my first curve. Okay, do you see some points like this? Okay, so these points, we can select them like regular points and move them around. Okay, what I'm going to do, okay, I'll show you how to do this again. I select the curve, and I'm going to go over here and say points on. Before I continue here, I just want to show you, I hope it stays on. But you'll see that above, when I hover over an icon, we get these 2 little representations of a kind of a mouse and a left click and a right click. That means that on the same button, there are 2 different commands. I can either turn points on by left clicking or turn the points off by right clicking. A lot of the commands have similar double sort of bipolar states, so you can run 2 commands from the same button. Anyways, just little things that we'll get along the way with Rhino. So let's go back to what we want to do, which is edit these control points. Now you should be an expert on where this is over here in points on. And we get access to the points. Again, these points have a certain relationship with the curve. This is a control point curve that is a 3rd degree curve. We might have not noticed this when we created the curve, but over here, when I do curve, there's something here that allows us to change the degree of the curve. Okay, I don't want to get too much into this at the moment, but if we would have drawn a degree 1 curve, let's say I would have drawn something like this. Don't worry about doing this. A degree 1 curve looks like what? A polyline, okay? It means that the control points are exactly, or the curve goes exactly through the control points, and their joints are discontinuous. There's no continuity besides the fact that they're, the points are on the same place, okay? Degree, if I, just to show you, if I did a degree 2 curve but with the same control points, now you start to see that although these 2 curves have the same control points, the points are influencing the curve in a different way. If I go now to degree 3 curves, each time we're changing slightly the parametric formula that eventually creates the curve. So there's an influence that the points have on the curve, and by changing the degree, we change the influence. We didn't notice that when we drew the curve, and at the moment it's not necessarily that important, but just so you know that that's why the curve is such and the points are off of the curve, okay, because it has a certain formula underneath all of this that takes the curves, takes the degrees, and eventually generates this form, okay. But anyway, so we can change the overall shape of the curve by selecting the point and moving it around, okay. We can move it if we just click and drag it, which is what I don't want you to do. It'll displace this point in XY, okay, because here we're in perspective mode, in perspective view, and that's the construction plane. But what I want to do is I want to move the point vertically, okay? And we could use the move command. So I could say MOVE, which is also down here, move. It's around the kind of copy, rotate, scale buttons. But if I say move and press enter, it's going to ask me where do I want to move this from. Similar to when we did copy, it asked us where we wanted to copy from. So I could eventually put some value here, but I know that I want to move it vertically. So because I know that I want to move it vertically, we get these other options in commands sometimes. These are kind of like hyperlinks. So if I click on it, I force it to move it vertically. It says vertical equals yes, okay? You see this? So now if I drag it around, if I click on somewhere, it doesn't matter where I click, but now I move anywhere, the point is forced to move vertically. And if I want, I can put an exact amount. Right now I'm not going to put an exact amount, but I'm just going to move it like this vertically. So let's repeat that from the curve. I'm going to select the curve. I'm going to turn its points on. Now I have access to the points. I can select it. I can move it, force verticality, and click somewhere to move it around. And if I press escape, I get out of the points on mode and I go back to the curve mode. So now we're aggregating quite a lot of things into this command. So I just want to make sure that our newly initiated folks are able to follow along here. Series of commands. In order to edit the curve, we need to get access to the control points. To get access to the control points, we need to use this tool here. Control points on. We can now select the points and move them, rotate them, do all sorts of things. Okay? That's more or less clear. Again, I'm kind of going through this Rhino part a bit quickly because I want to get to the good stuff in Grasshopper. All of this stuff in Grasshopper can eventually be automated or done in a different way. So we have 3 curves, and what I eventually wanted here is to create a loft from these curves. Okay? So a loft is eventually going to be a surface. So it's probably somewhere, the command is somewhere underneath this surface menu, and it's going to be here. It's the second element. It's loft. Okay? You can guess that probably the command for this is loft, L-O-F-T in the command line. So right now I have nothing selected. I've clicked on the background of the perspective view or any view to make sure that I have nothing selected. Okay. I'm going to go to Surface, Loft, and the command is initiated. So it's asking me which curve do you want to use for this loft. And well, you probably can guess we're going to use the curve that we've drawn. All right, so I'm going to select 1, 2, and 3. And I'm going to press enter as it's telling me. Press enter when you're finished selecting the curves. Okay, the command line always tells you what you should be doing. Okay, so it's a good idea to always be reading the command line and just be aware of what it's telling you to do. You're going to be your best friend when you're working in Rhino because it's going to try to guide you during the command. So right now I'm done selecting curves. I don't have any more curves to actually choose, so I'm going to press enter. And it's giving me something funky here for some reason, but it should give us this little window, okay? We have several different kinds of lofts we can make. For now, I'm just going to make a normal loft. Somehow, I don't know if you get the same sort of result, that we get this weird thing here, but somehow it's changed the direction of some of my curves. I don't know why. But I'm just going to say here if your loft looks like this in the preview, I'm just going to say align curves. Wait, let's start this again. Escape to get out of the command. Maybe let's try to select the curve first and go to surface, loft. Okay. It should look something like this. Okay, and right now, we don't actually have the surface. We just have a visualization of what the surface eventually could become. Because here we can change all sorts of different parameters, make the surface do different things. But we're just going to keep this a normal loft. We're not going to simplify anything or align it. We're just going to say OK. And now we have our surface. Okay, so this is an open surface because it's just one face, let's say, of a surface. But now, if I, for example, change the underlying curves, for example, let's say that I take this curve and I move it somewhere. So I'm going to click and drag it away. You'll notice something, that the surface stays exactly the same as it did before. Okay, in programs such as 3D Studio or Maya, this is already connected together. I mean, you move the parent curves and the child updates along with it. Okay, Rhino is not associative by default. It doesn't. I mean, obviously, you saw that the curves and the control points are associated. So you move the control points of the curve and the curve updates. But when you get to things like this, when you're taking objects and creating objects from them, the parent objects are not necessarily tied to the child, to the child that it generates. So the surface stays still, and essentially we would have to recreate the loft if we wanted the loft to now take on these three curves. We could delete the surface. We could go back to our curves, loft it, and we'd get this again. But we're always going to have the issue if we somehow change our minds and want this loft to be something else. If we change our mind, then we're always going to have to go back and reconstruct it. And this is where eventually the folks at McNeil devised something with Rhino. I guess it started in Rhino 4, and you can barely see it down here, but it's something called record history. Okay. Record history is a way for you to execute commands, and the system sort of keeps track of the elements used to run those commands. Okay, so this is part, and I'm just going to kind of change a bit my screen here so you can see what I'm talking about. So down here, we have a series of drawing guides, drawing aids, things like orthographic drawing, which you should be quite used to, object snapping, and a few other things. But over here, we have record history, okay? So now we're going to execute the loft command, but with the record history turned on. Okay, so we can see that actually we do have the ability to set this kind of thing up. Okay, so before I do anything, I'm going to say record history. I'm going to click on it, and it's going to be bold. It means that it's activated. You have no other sort of signal that the command or the mode is operational besides this boldness that it has on it. Okay, so we turn this on, and now we run the command as we did before. Okay, so I'm going to select the command, the curves. I'm going to say loft. The loft looks exactly the same, and I'm going to say OK in the exact same mode as I did before. And it seems that life is just as it was a minute ago. Okay, but now if we select the curve and we move it around, you see that the loft remains connected, updates according to the curves. Okay, we could even go and select the curve itself, go to the point, control point level of it, change the control points, and everything remains the same. Okay, the loft updates to respect its parents. The parents are the curves, and the loft will always respect that. Now, one issue here is what happens if then you try to take the surface and move it around. It says this: dragging broke the history on an object. Okay, that means that we tried to modify the child, and the parents haven't been modified. Okay, we can never go. We can only go, let's say, from left to right, meaning that if we have our parents here being the curves and we have the child here, we can't change the objects downstream. We can't change it's one directional. We cannot change the child and then update the parents. It's only one direction. Okay, so you're always going to run into this issue. In order to restore that, you have to undo to get the child back to where it was before, and then history should be restored, and we should be able to, maintain that. So this is great, but what's the problem here? That logic, let's say that I save this file, and I am working with Mattia, and I pass this to Mattia the next day, and I don't tell him anything about this. Okay, he's working on the file, and we can aggregate history-enabled commands. There's maybe like a group of 100 history-enabled commands that I could eventually do some more complex things in here. So let's say that I had done several things to this, but I didn't tell you about it. I didn't make any notes about it. There's no signal that these things are connected. And eventually you could start maybe, okay, well, I don't like where Luis has put the surface. I want to move it around. And you'll start to get all of these errors about dragging broke the history on an object, etc. And you're going to be like, well, I have no idea what's the parent. I have no idea what's the children. There's no visual indicator of how the logic is set up. Okay, this is what Grasshopper is for. Okay, Grasshopper is a visual logic modeler, let's say. It allows us to literally connect things together and show how that logic is created. Okay, so you're working more at the logic level and less at the, let's say, modeling level. You're modeling, but you're modeling the operations that it took to create this. Okay, let's try it out. All right. For now, I'm going to delete the surface. I'm going to keep my curves, and I'm going to show you a little bit about what I mean by this logic modeling. Okay. If you haven't run Grasshopper yet, Grasshopper should initiate by just running the command Grasshopper. Okay. By installing this plugin, now Rhino has an extra command. Okay. The command is Grasshopper. If you haven't installed this plugin, then that command doesn't exist. Okay, and this is the same with any plugin for Grasshopper. You're essentially any plugin for Rhino. You're essentially adding new commands to the Rhino interface, or maybe even new menus, etc. But as soon as I start writing Grasshopper, you see that Rhino starts to detect that that's what I want. If I press Enter, then I should initiate the Grasshopper environment. Okay. Everybody get this thing popping up? Fantastic. So okay, let me take a pause here to get you no, I don't. I have Grasshopper for Rhino 4, but I don't have Rhino 4 here. Okay. So the Grasshopper interface, and here I do want to take a little bit more time to just explain what's happening here. First of all, we're going to operate on an area of this interface called the canvas. Okay, on the canvas is where we're going to be, let's say, recording and drawing our process. This canvas is going to eventually host a series of objects that we call components. Okay, and it's a little bit, let's say, tricky, the nomenclature, because maybe we're talking about components on a facade or components on a building or something. But your components are just the functions that create our process. Okay, a component, for example, eventually that we might want to try to use is the loft component. So just like we have a loft command here in Rhino, we usually have some sort of analog of those commands here in Grasshopper. To get over to the loft component, we have to think, okay, what eventually am I generating when I create a loft? Well, I'm going to generate a surface. So that's probably somewhere over here in the surface tab. So if I click through, we don't have to click all of them, but all of these areas hold different components that do different things. Okay, they're typically organized in a pretty topological manner. So anything dealing with generation of surfaces or their analysis, their decomposition, composition, etc., is going to be here. Same with elements, components dealing with curves. If I want to split a curve, join a curve, make it longer, create basic curves, create complicated curves, divide curves, know how long a curve is, all of that kind of stuff is going to be in this curve area. Anything dealing with points, vectors, making grids of points, and some other funky things are going to be here in vector. Anytime we want to transform, move, rotate, scale, morph objects, we're going to find them here in the transform area. Anytime we're trying to find intersections, Boolean differences, Boolean unions of objects, we're going to find them here in intersect, et cetera, et cetera. Now, I have a whole lot of extra component areas, and besides, after transform, up to transform are the default components. This is what you get with Grasshopper. If you just installed it, this is what you'd get up to here. But we've also installed some plugins, some add-ons for Grasshopper. So you'll have new component sets that add different functionality. I have probably a few extra that maybe you don't have. I also have some custom objects that I've defined to extend the functionality of my Grasshopper installation. But for the most part, we're going to today be dealing with just the default components. Eventually, in subsequent tutorials, we'll deal with some of the add-ons that we've installed. So let's get back to the task at hand. We also, and I haven't mentioned them yet, we have all sorts of other things in the menu and a couple other, let's say, aids and tools that will only become really relevant once we start drawing things here on the canvas, okay? To move around in the canvas with the right click, you can pan around, you can also zoom. Right now, it doesn't seem important why you would need to do that, but eventually the Grasshopper definitions, which is essentially what we call the aggregation of these components together and their connections, the definition, can become quite large, and then zooming in and zooming out is very important. So to the task at hand. We were talking about how to do the analog representation of that surface we created in Rhino, but here in Grasshopper, okay? So like I said, we're generating a surface, so probably we're going to be wanting to look in this surface area to see what we have available to us. Now, is a loft considered a primitive surface? Well, I don't know. Depends on how David had decided to organize it. But effectively what you'll see is that what is termed as primitive are things like more things that can be defined more from the basic parameters. So a sphere can be defined from a center point and a radius, okay, a cone, a cylinder. These kinds of things are what are called surface primitives, okay? A surface, a loft is a much more free-form surface, okay? It has many more complex rules that could eventually generate it, okay? You could generate what looks like a sphere from a loft if you had many arc sections and you lofted those together. But what we have here in freeform are things that are, more made up of other objects, other geometries, rather than just parameters. And what I mean by that, like I mentioned, a cylinder can be made up of a center point and a height. Okay, so from two heights, or from 2 points and a radius, you can create a cylinder. You're not creating curves to then create cylinders. You could loft. Can somebody see if somebody's at the door? It sounds like somebody's knocking. You could create a cylinder by lofting two circles, but you can also create a cylinder in a much more primitive way without actually ever drawing curves in the first place, just by drawing points and defining a radius. Same with a cone. You can define a point, a height, and a radius. These are not, they are geometries, but they're much more basic geometries. When we start to deal with creating geometry from other objects like curves, etc., then we're here in the freeform area. And to our surprise, look, we have the loft component. Okay, so I'm going to click over here in surface. I'm going to click on freeform, and eventually when I get to loft, I'm going to click it. It's going to make all that go away. My cursor changes its representation to this kind of little box, and then I click again on the canvas, and things change, and I get something like this. Yes? Try that again. You can also click and drag. That's super annoying. You can click and drag, but I usually just click and click. So surface, freeform, loft. Click, click. And congratulations, my friends, just starting to use Grasshopper. You've introduced your first component to the definition, okay? Half the battle is well, let's say 15% of the battle is this. Just knowing how to put things on the canvas, okay? Second part of it is reading what this thing is, okay? What is this weird thing that we've put here? Now, we have to think this about this little object, this component, in an abstract way, because 90% of all of the components are going to be able to be read in the same manner, okay? They might have different number of things that you need to plug into them. They might have different number of things that they generate, but they're always going to have inputs and outputs, and they're always going to have some zone in the middle that gives you other options, okay? So let's learn how to read this thing, and then I will also show you that a lot of the other components, most of the other components, if you didn't know how to read them, you can pretty quickly figure out what they need in the inputs and what they need in the outputs, okay? First of all, your components might look different. They might look like this, okay? They have the text representation of what they actually do, their title. I prefer to look at the icons, okay? I just think it works a little bit easier, and it, especially because sometimes I'm teaching people from many different parts of the world, and it's just easier to communicate with a graphic. So to make your components also appear with icons, you can go to Display, Draw Icons. Okay, and you see these little icons. At first, the icons can seem maybe a bit strange and abstract, but I think after a while, I mean, David actually spends a lot of time on the icons, which is very, actually, kind of a good thing. The thing about David is that he's not only a decent programmer, but he's also great at sort of visual representation of what he's programming. And this is something that you rarely find, that a programmer is, I mean, now we have people using, for example, a software called processing that are actually great in representing information. But I think David is a rare case that can, I don't know, sort of bridge these two gaps. So the icon representation is really, I think, something he spends quite a lot of time on. I think a good percentage of the time, along with developing Grasshopper, is developing these things. Now, you can't say the same for the add-ons, because the add-ons aren't necessarily created by him. Actually, none of the add-ons are created by him. So, for example, when we see Jihow, this is a set of components that I worked on with a few other folks. We created the icon, and maybe they're not as representative as what David's doing, but he has less control over that. So a few other things you might notice is this strange little timer thing. I'm going to turn that off. Eventually, later on, I'll show you what that does. But it's a way to understand what parts of the definition are taking longer to execute. So maybe you have some very complex thing happening, and you want to see how to speed it up or where the bottleneck is in the logic. And this is a way to test that. So it's a part of a series of widgets that you can find here in display canvas widgets. I'm just going to turn off what's called profiler. Okay, to just have this. Okay, so this component already, even without doing anything to it, it's telling us a lot of stuff. Okay, first of all, you'll notice that it's orange. Okay, and the components, maybe if you have it selected, it's kind of greenish, but deselect it by clicking on the canvas, and you'll notice that it's orange. Okay, you'll also notice that it has a little bubble, kind of a speech, kind of a cartoon bubble above it that is trying to tell us something. Okay, when components are orange, it means that there's something strange that's happening. It's a warning. It doesn't necessarily mean it's not gonna work or give you something. It just means something's wrong. Okay, and maybe because something's wrong, it's going to give you something weird. Maybe something not exactly as you expected it. Okay. In this case, you could imagine probably what's wrong. We're not giving it any information. Okay, it's a loft, but you saw in the loft command, the loft needs curves to work. Okay, we haven't given this component curves, and it's not just going to magically guess that we want to loft with the curves we have in Rhino. You have to tell it which curves it specifically wants you to loft with. Okay, so if we just hover over this little window, it says warning, input parameter C failed to collect data. Okay, input parameter C. That's just the technical way to say that, hey, I have nothing connected here in C. I need something there in order to work. What's C? If you just bring your mouse over and just hover in it, just don't click, just hover your mouse over C, just put it there, you'll see a few things. First of all, it's kind of guiding us and telling us that these little elements here and these little half circles are actually inputs. They're places that we're going to connect other things into. In this case, C stands for curves. It wants a list of curves in order to make a loft. Well, it's the same thing. We provided the loft command over here. We selected these three curves, and then we had kind of a list of curves. Okay, but somehow we need to feed the loft component with those curves, and we'll see how to do this in a second. But a few other important things here, and the guys in Mumbai might not hear me for a second, because I'm just going to go up to the screen, but I'll come back here. I want to explain really well. Okay. And by the way, the same kind of thing is going to appear when we go over here. We get a little icon. In this case, the icon is kind of a little cylinder extruded. And it's just telling us that this is going to eventually generate some kind of surface or polysurface, depending on the curves that you give it. Okay, so this is the result. So we have inputs that are going to feed the loft command, and we have outputs that are going to be the results of the loft command. Okay, so first thing we need to do is we need to give this component curves. I can draw curves, or I can generate curves in Grasshopper, but actually I already have 3 curves that I've drawn here in Rhino. So I want to show you now how to connect these curves to your logic here in Grasshopper. Yes? I deleted it. I selected and I deleted. Yeah? Okay. So there are several ways that you can connect geometry in Rhino to the definition here in Grasshopper. Okay, I'm just going to show you the most basic way that all of this happens. Anytime that you have something drawn in Rhino and you want it to be part of your Grasshopper definition, so Grasshopper is aware of it, we're going to go over here to this area called params, and there's a first area called geometry. And look at all these icons. These are these icons that I'm talking about, okay? Curves have this curve icon. If we were, instead of a curve, trying to connect a mesh or a surface, we could use these icons, okay? But right now, we have curves. So I want to use this component to connect the curves that I have in Rhino to Grasshopper. So I'm going to go to params, geometry, and curve. Okay. Notice that the curve component is also orange for the same reason. It's just an empty container that eventually can hold curves. But right now, it doesn't know which curves to hold. It can hold this one, or this one. Okay. So because in this case I have 3 curves, what I'm going to do, I'm going to copy this, Control-C, Control-V, and then I'm going to have one for each of my curves. Later on, we'll see that this isn't necessary, but I just want to show you this part first so you see how this works. Okay, so with this box, with this component, I'm going to reference the first curve. With the second component, I'm going to reference the second curve. And with the third component, I'm going to reference the third curve, okay? Now, how do we actually do this? And this is another thing that is also sort of universal for Grasshopper. Anytime we're defining an object, even a number, what we can do is in the center of the component, this particular geometric parameter, I'm going to right-click, and I get a new menu that pops up. This menu has a bunch of stuff that eventually will be useful, but the one I'm looking for is this set 1, okay? In this case, it's set 1 curve. When I click this, what's going to happen is that Grasshopper is going to go away. I'm just going to see Rhino, and in the Rhino command line, it's going to ask me which curve is it that I want to reference, okay? So I'm going to click here, set 1 curve. Grasshopper went away. Here in the command line, it says curve or edge to reference. So I'm just going to select my first curve here. And automatically, Grasshopper pops back up. And notice, hey, it's turned to gray. Okay? When it's gray like this, it means that it's okay. Everything's fine. For the most part, I know what I need. I'm happy. I'm satisfied. I'm no longer angry. You've fed me with the right thing, okay? If you select the component, it turns green, and it should give you kind of a green indication in the Rhino window of what geometry it is that is referencing. My colors are a bit different because I could no longer stand the green and red after so many years of working. I hope I'll show you eventually as well how to change the colors so you can look like pros. But you should be able to select the component, and it's hard to see here in my window, but eventually you get an indication of what that geometry is in Rhino. Okay? So repeat this for the other two curves. We right click in the center, set one curve, and we select the middle curve, and Grasshopper comes back. Right click, set one curve, Grasshopper comes back. If we were to be referencing a mesh or another type of geometry, it would be similar. We would just need the type of geometry component here. We'd right click it and it would say, for example, set one mesh or set one surface or set one point, for example. Because we're using curve, here it says set one curve. Okay. Some of you smart folk, which all of us here are, might already notice that we have the option to set multiple curves. We can actually do all of this that we've done just in one component, but I want to go bit by bit before we get to these kind of options. Okay. Now, yes. 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 Exactly. Exactly. Because yes, eventually, what if we had 100 curves that we were going to loft? This would be already. I would not use Grasshopper if I had to put 100 of these components to do one by one. So actually, yes, we can do multiple curves, select them all there, but we'll see bit by bit how to go about this. Okay, because we have 3 curves, it's fine. We can illustrate the point this way. Okay. Now comes the next 50% of Grasshopper knowledge. You have about, let's say, 30%. We had the first 15% by dragging the components here. We had another, let's say, good chunk, let's say 35% by knowing how to read the inputs, the outputs, and knowing that if we click in the middle, we get a different set of menus. We click here in the middle, we get a different set of menus. So already we have a lot of what we need to know in Grasshopper. The biggest thing here, the most important thing, and why Grasshopper essentially works, is that we have these little half circle nubs. I don't know how better to call it besides terminals, I guess. Nubs is a much more entertaining word to say. If you hover over them, you see that your cursor changes to this kind of, it has this little cable with an arrow, okay? Now if we click and drag and start to move our mouse, we see this kind of cable coming out of there, okay? And it needs a place to go. We've dragged this from an output. Output needs an input, okay? So if we start to find some inputs without letting go, you see that it wants to snap to these inputs, okay? So I'm going to click over here to see. It's going to snap to that input, and then I'm going to let go. And if you've done this successfully, you've unlocked the next level of achievements in Grasshopper and learned how to do almost everything you need to do to operate Grasshopper, okay? But I don't know why it's generated somewhat. Yeah. You see that the loft component has turned gray. So somehow it seems like it's okay, but it's still not okay. We cannot make a loft just from one curve. Let's look at the output, the resulting output of the loft, just hovering our mouse over L. You see that the resulting loft surfaces is null. Null means, well, no, there's no surface here, even though the component should have turned red or said, for example, I don't know how to make a surface just from one curve. But anyways, it's not turned red. I think in previous versions it turned red, or it gave you a warning that said, I don't know how to make a loft from just one curve. Okay. So, well, we have other curves that we can use to do that. So let's try now to do the same thing we're going to release, take the cable from the second curve and try to connect it to the same input, okay? And we see that Grasshopper doesn't allow us to do that by default, okay? But we can force it to connect more than one input into C. What we need to do is once we have the cable out like this, we press Shift. And if I press Shift, notice that my icon that was once before kind of this gray arrowhead and cable now turns to this green arrowhead and cable with a little plus sign. So now if I go to C and let go, something's happening now. I get a visualization in my Rhino window of something that starting to look like a surface. And over here in L, instead of null, I have a new result. It's an untrimmed surface. And we'll talk about what trimmed and untrimmed are later on. That's not so important at the moment. The important part is that we've now successfully created a loft out of two curves. And if we actually continue on and do the same process, pressing Shift and adding the third curve, we now have the surface. If you press Shift, it does this. You're pressing Control. You got to press Shift. So what has just been discovered over here is actually if instead of Shift, you press Control, it removes the input. So it's the opposite behavior. So if we're taking here Shift and we press Control, we can remove the input from that connection. Shift allows us to aggregate inputs. Control allows us to remove inputs. Yes? Yeah? If you right-click on the C on all the inputs, you can do the same stuff as what we've done out here. Exactly. Yeah. So what has been pointed out here is actually all of this. I could actually even do just directly from the input. Now I can't. Now these options are grayed out because I've connected something. This input is inheriting information from an external source, here being these curves. But if I had disconnected that, I would see that I could actually just select multiple curves from that. I prefer not to go this way because what happens, for example, if I wanted to use the curves in another situation? You know, I wouldn't have access to them like I have access to them here. I would have to extract them. So if you know that all you want to do is create these blocks from the curves, then you can do it like this. But in order to be more adaptable or more future-proof, let's say, you could kind of do this sort of more laborious way, having your curves out here, and then having the component inherit that information from an external source. Okay. So friends that have just started Grasshopper, congratulations, you passed the hardest part. I mean, this is true and this is false because, of course, now it's up to us to see how we can start to compose all of our ideas with this tool. Okay. But a couple of things to note now that we're here. We move our parents, and for free, we already get the fact that the loft surface is updated with this, okay? We don't have to do any record history. This is inherently recording history, okay? When Grasshopper first came out, it was called explicit history, okay? It wasn't called Grasshopper. It was called explicit history because of this. You're explicitly defining the logical diagram of your process, okay? If we decide to change something, your logic is already recorded. We don't have to change the logic. We just have to change the parameters that are being fed into that logic, okay? This is a very simple definition. It just takes some curves and makes a loft, okay? But it already can start to show us a lot of the importance of working in this way, okay? Again, some things to note. If we select the component that is essentially generating our our object, we get a preview or some kind of indication that this is what we are selecting. So I'm selecting the lock component, and because the result is this lock, I see that indicated in the Rhino window by my geometry turning a different color. Or for you that are just started, it's probably turning green. For me, it's turning magenta. Okay. A couple other things to note. Try to select the surface in Rhino. It doesn't exist in Rhino. Rhino only knows that it's sort of a ghost. It's a potential geometry that maybe eventually you might want to use, but it's not using it yet. And it's something that we have to get used to, that we're operating in Grasshopper. We're not actually, we can't touch the geometry outside of this logic, okay? A consequence of that is, let's say that I had created a beautiful surface, the most beautiful surface anyone has ever seen, and now I want to render it, okay? If I go to over here to my renderer, I get nothing. Rhino, the renderer, nothing is aware of this geometry except for Grasshopper, okay? So that seems kind of strange, no? Why would we work this way if eventually we can't render it, we can't do anything with it? Well, it's not that we can't render it, it's just in the current state, we don't have any geometry yet to render. This is just a preview, okay? It's a potential thing that maybe we want to render. A couple other things. If we zoom in close enough to the edges or to some of the elements of this surface, you see that it's kind of a rough thing, you know? In Rhino, when we created this surface, if I say loft here, you see that it's this beautiful, smooth, continuous, infinitely continuous element. It's just, you know, it's just a beautiful example of continuity, and we don't see any of this roughness, okay? This is just another, you know, Grasshopper has to work on previews and instances, and it has to be always updating. So it's doing everything possible to draw the most minimal amount of geometry as it can in order for it to be flexible, adaptable, quick, and agile, okay? So it's just a preview. It's a rough preview. We can do a few things to make this a little bit more true to what it actually would be. So to change this to be a more smooth representation, over here now we start to see some of these other aids in the interface kind of come to life. So way over here on the right, we have this blue sphere, which is the, let's say, the resolution setting to our geometry. So if I go over here to high quality, and it might be hidden if you have this too small. You might not see it. You might not just see a pencil. Yeah? One of the little differences. So if you're on Rhino 4, and if you're using Grasshopper for Rhino 4, then yes, you might not have this this thing here, but I'll show you eventually where to find it. Okay, it has it somewhere, just not broken out here. If you're in Rhino 5, to kind of increase the resolution of the display, how it would look more so in real life, you can go here to and change it to high quality. Okay, and you'll see now it's much smoother. Okay, it takes a little bit longer to update, but we don't notice that lag here. It actually updates almost in the same amount of time, and we don't notice it. Maybe it takes a few new milliseconds to go. Oh, that's not right. So that's just one thing. For folks in Rhino, Salud, in Rhino 4, let's see here. Well, let's take a look at a couple things. I think it'll be here. If we right-click on the canvas, you should have an option for preferences. Yeah? Okay. If you don't have it there, maybe go to File Preferences, please. Have it there. Okay, edit preferences, it's got to be there somewhere. So for folks using Grasshopper for Rhino 4, you're going to find the preferences in window preferences. Okay. For us using Grasshopper for Rhino 5, we have preferences, and we also have, if you right-click on the canvas, you can get to preferences. Okay. Let's see if these are different too. So a couple of things. Let me see the display category. No. Interface. It takes a little bit of time to kind of update these. Maybe I'm mistaken in terms of the that these things actually exist in here. I mean, you can do a few things. You can do the like add a who the author is to the definition, these kinds of things. One of the things I wanted to show is, first of all, in the viewport. You guys have something called viewport? Yes. Okay. Good. You can change your colors. Okay. So please, everybody, change the default colors that we have, because I get sick to my stomach seeing red and green. I don't know why. It's just I just can't handle it anymore. To do this, you have two different options. You can change this at the document level, so just this particular document, or you can change it for every new document that you generate. Okay. To do this, if you right-click, you get this kind of color picker that is like in 3D. You can move this around, okay? And you can also use these bars. But I recommend using kind of a muted color and also giving it some transparency, okay? If you don't give it some transparency, then it's going to be a solid thing, and it might be a little bit hard to see. Okay, so choose a color. I'm using kind of a gray and magenta. If you want to choose something similar to me, you have two different color choices. I think this is HSB color, and this might be a different kind of color profile. But if you switch this, you also have a color picker. But if you switch this kind of color mode, you get two different ways of choosing color. One just kind of is a single color and then grayscale. So you can choose a grayscale, and you can also choose a kind of level of transparency. Okay, and it's automatically updating the color. And if you right-click on the other one, this is what's going to be chosen when you highlight the component. So it's going to be your kind of selected highlighting indicator. So I chose magenta in this case because it's the best color. I think we can all agree. Now choose whatever color you feel is best for highlighting. A nice kind of baby blue also works really well. But yeah, just choose a color that you feel comfortable with. I also added some transparency to this because it'll eventually help to see what's happening. Okay, so that's for the default template. So any new file you create is going to be generated with these colors. If you want to apply these same settings to the current file you're working on, you can actually just click and drag down to the document. So you just literally click and drag the color down. So if we have this defined, you should now have a much more professional looking system. Now, for people on Rhino 4, I'm going to have to see where this preview is. Okay, so now your definitions will look like you've been using Grasshopper at least for 2 years. because that's about the time it takes for somebody to get sick of the default colors. But it's also nice when you take screenshots. It just makes for a not so rookie looking definition. And this is really not important. It's just a kind of a vain thing on my part. But anyways, okay. Let's see what else we can discuss here. So previewing. You might have a few icons that look something like this here. And these are just the kind of preview state of Grasshopper. So right now it's kind of drawing everything in a shaded preview. We can also just draw things in a wireframe preview, or we could just hide everything that's happening in Grasshopper altogether. Okay? It doesn't mean that it's not computing what's happening here. So if I move this here, I'm computing the underlying geometry. I'm just not showing it. Okay? And again, you can go back to a wireframe view or the full shaded view. This is gets to be more relevant when we have a lot of geometry and it's taking maybe more time to generate the preview for it. But for now, the preview is happening quite rapidly, so we don't have to worry too much about that. You can also do this at an individual object level. So for example, if we were doing something beyond here, but we wanted to turn off the preview of the surface, we can select the surface, right-click in the center, and we can select preview, and the preview goes away. Again, it doesn't mean that the surface isn't being computed, it's just hiding it. You can't see it. And the component reflects that by being gray, a little darker gray than normal. Okay? There's also enabling and disabling, and this actually does mean that the component isn't being computed, okay? And anything that possibly was connected down here will also not be computed, okay? So you're essentially creating you're disconnecting without actually disconnecting. You're just saying that this is not going to be calculated, and now it's turning even the icon gray. Everything is kind of a ghost thing here. So now there's not going to be any solution generated after this, and even if we change these things, nothing's going to be computed. So again, if we want to enable this back, we can go back here, right-click in the center, and say enable. Now it's just hidden, and if we want to show it again, we can click on preview, and now we get it back. And maybe one of the most important things as well is, okay, let's say that I've done everything I want to do to the surface. I've modeled it, tweaked it. It's fantastic now. It's exactly what I want, and I want to render it. I want to do something with it. Okay. Well, you probably noticed that you have a third option here, which is to bake it. It's this little fried egg icon. Okay. And baking is cooking it. It's making it, generating it in Grasshopper. Okay. So if we say bake, here we get a little extra window that eventually allows us to tweak some of the like which layer it's going to land on, etc. Okay? Don't worry about changing anything right here now. Just say OK. And finally, we get the surface selectable in Rhino. Now the preview is probably looking pretty fugly, pretty ugly, just because now you have the Grasshopper geometry on top of something we see in Rhino. So it's trying to show both of them at the same time, and it's not having a very good job. It's not doing a very good job because they're in exactly the same place. So you get these kind of artifacts. But for example, we can now select the surface and move it away. And of course, if we wanted to, we could render it. I don't know what it's going to look like, but it's going to look like this, just a quick render. But this surface is no longer associated with our geometry and our logic in Grasshopper. So if I go back to my parent curves and I change them, I move them around, you'll notice that the surface doesn't update anymore. Okay? it's disconnected, it's disassociated, it's no longer connected to our logic. It's Grasshopper is concerned, they've split up. Okay. I'm sorry? If you don't move it, then you're just going to have a mess. You're going to have, it's never going to change. It's baked, it's disassociated from the logic here, okay? We could reintegrate it to do something else with it because it's a surface, it's a type of object that Grasshopper understands, but this, you do this baking when you're ready to, I don't know, render it, when you're ready to fabricate it, when you're ready to, you know, then export it to something else, okay? You are disassociating it from the Grasshopper geometry, but then that means that we can do everything else with commands that can take surface, then we can apply it there, okay? So just a few things about that. Eventually, if I wanted to add this, I would have to then select it, bake it again. Just to note, all of these things we're doing by right-clicking in the center of the component works on one object at a time. Right now, I am only baking one object, but if we had multiple objects that we wanted to bake, we could also right-click on the canvas, and we get the preview on and off, we get the enable, disable, we get the baking, etc. And this is more useful, and this is what I usually do, because it also works for multiple objects. But you select the object you want to bake, you right-click on the canvas, you get the menu, and then you hit bake. If we do it this way, we don't get the option to decide which layer it's going to go on. It's just going to land on whichever is the active layer in Rhino, which right now is in the default layer. So it's just landing in the default layer. Okay. Any questions thus far, my friends, starting with Grasshopper? Any comments from people who have used Grasshopper before? Okay. Of course, if we use Grasshopper before, we know that there's Grasshopper can't be defined as, well, this is what it can do, and this is how we do it. For every person, there are millions of ways to do the same thing, let's say. You could approach it in many different ways. What's good about Grasshopper, what's interesting about Grasshopper, what's also difficult for people who are just starting to use Grasshopper is that Grasshopper is a tool for making tools, okay? It's not, it can't be defined by a specific task or a specific, any sort of function. It's for you to kind of imagine and record your process and create your own tools from it. Okay. Here we've just created a very basic tool. I mean, we can do this also in Rhino. We don't need Grasshopper for this, but it just illustrates how we can start to use Grasshopper. Okay. Let's do something with the surface that we have now. I mean, we have this beautiful surface. Let's try something with it and see what else we can do. And this is just going to be kind of silly. I mean, we're just going to make some kind of crazy stuff, but just so you can see a little bit more of what we can do now. We've created curves, now we have the surface. Let's do something with the surface. Something really nice about NURB surfaces in this case, which is eventually something we are going to have to talk about and define, the fact that Rhino is a NURBS modeler. Does anyone know what NURBS stand for? Non-uniform rational B-splines. Whoa, what the hell is this? It's fundamentally different from meshes, okay? If we're working in Maya, 3D Studio, etc., these are excel and are extremely good at working with mesh topologies, okay? In the last 5 years or so, they've both taken on NURBS, and if you use Maya extensively, you know that it has something called subdivision surfaces, which are really cool. All of these are different topological concepts of how to construct geometry. NURBS is something that Rhino excels at, and eventually we'll have to see the difference as we go along. But in this case, we've generated a surface out of a series of curves. The surface is can almost be considered as infinitely continuous. Okay, there's a continuous transition between any point on the surface and the next one. Okay, the surface happens to be curved, so there's also that embedded into it. It has all this curvature that we could eventually extract. A mesh, on the other hand, while it can be seemingly just as smooth, it's made up of a series of faces, points that create faces. Okay, these points are very interesting, but eventually we have a series of let's say triangles, quadrilaterals, or polygons that create these faces. These faces added together creates the whole mesh topology. Okay, so it's kind of a bag of points and how those points create faces. While that might not seem that different, the types of objects we can create with one or another are very different. Okay, and we'll get along with this. Right now, we don't have to worry too much about it, but what I'm going to do now is I'm going to place some objects on the surface. Okay, and I'm going to place them in such a way that they are oriented normal to the surface. Okay, so I'm not just going to orient them in 2 dimensions, this kind of flat, but I'm going to use this beautiful curvature that I have on this nerve surface to extract all sorts of orientations. Okay, and I could do this again in many ways, but I'm going to use a kind of a prepackaged component that I have here in Surface Utilities called Surface Frames. Okay, and the surface frames, I'm going to give you about 5 minutes to read the component and try to just imagine how it is that you could satisfy its needs. Right now it's angry at us, it's orange, it doesn't know, it's saying, hey, I can do so much stuff, I'm ready to do something for you, but you're not helping me out here, you're not giving me any information. So I want you to give it a try, just hover over the inputs and see if we can kind of imagine what it is we would need. There are some very important things that I haven't shown you yet that you will need to complete this, okay? And eventually you're going to get to that point and you're going to see what that's going to be, okay? But just try to bridge between the surface and this component, see if you can make it work, okay? For the newly initiated, take a few minutes to just give this a try. See if you can try to read the component and get it to work. Oh. We know we need to make a cable connection from one to the other. The number of times. Yep.
We are dividing them sometimes. That's why I have to take it. Things like you change topology on that.
If you want to change it, it's just this one, then I think oh, this one. This one.
Here, you can generate it in Grasshopper. I'm just going to store it here.
Yes.
Okay, perfect.
So by now, you've probably seen some interesting things happening. So if you do this connection, look at your and now we've created a new kind of object that we haven't spoken about. Okay, we've spoken about curves. We've seen briefly some control points. We've now seen surfaces. In this case, lots of surfaces. And this component generates a new kind of object, new kind of piece of data that we haven't seen before. And if we hover over the outputs, we also see something quite different that we'll have to explain here. We can kind of rotate around and see all these things here. If you kind of zoom out and you see the default Rhino world, we have something similar. You know? We have something that's indicating an x-axis, a y-axis, and a kind of a grid. Okay, and what we have now is many of those. Okay, we've just created a bunch of those. We see orientations x, y, and z. Okay, so now we have a bunch of new local coordinate systems that are on our surfaces, and any component that takes a coordinate system as an input will be oriented here. Another thing to just point out is that we have this other little icon that's indicating what it is that we're making. So we're creating these little construction planes. Okay? All of the inputs and outputs will have these kinds of icons. Okay, if we select them, we get like this. They might be a bit big, and there's ways to change the display of how they show up, but for now, let's just leave them like this. Now, you might be wondering, okay, so I connected this together and something happened. I get a bunch of them, but I never said how many I wanted, or how, you know, somehow the components, these elements here are empty. Okay, we haven't connected anything to these elements, but somehow it's magically just decided that we have these construction planes, and I haven't done much to set that up. If we hover over U and V, we get this icon with a 7, okay? And that's the icon for an integer, a whole number. You should be very familiar with integers. And by default, this component has 10 and 10 in U and V, okay? If you've done any sort of texture mapping before, maybe this U and V starts to make some sense, okay? A surface can be thought of as a two-dimensional world, okay? If you're a citizen of this surface world, you only see in front of you and behind you, to the left of you, to the right of you. You have no concept of up and down, okay? We, as external viewers of this world, looking at this surface world from the outside, we do see that it morphs in space, that it is 3D. But if you're a citizen, if you only know the world of the surface, you don't know anything about up and down. You just know about forward, backward, left, right, diagonally, etc. It's two-dimensional, okay? And this is what the U and V is setting up. In the U dimension, how many construction frames do I want to set up? And in the V dimension, how many construction frames do I want to set up, okay? Now here, we can, as was pointed out before, actually introduce this number directly into these inputs. I could right-click. When I right-click on the input, I have here set integer. And you see, It's kind of tricky at first because there's a lot of other options and you might like activate something else, but just carefully try to go over here to the right or the left of your set integer and change this number 10 to 30, for example, and say commit changes. And try the same with v. Set integer, go over, and change it to 40, for example. And you see that this way you can introduce new values into u and v, and we can, let's say, increase the resolution of these construction planes. Now there's so many that it's even hard to see an individual. Okay, so inputs to components also allow us to define them in this way. We can right-click on them and define what it is they need to operate. But having to right-click and set this up all the time also might seem like a kind of a tedious task, no? So there are, of course, other ways we can introduce numbers. If we go back here to params, in primitive, we have some primitive data types. Integer is the one that we're talking about, and we could bring out a component and set it that way, but it would be doing essentially the same thing. Over here in input, we have some interesting ways that we can start to introduce some values. The first one is the panel. Okay, the panel has several different functions. If we click and then put it here, it's kind of like a little post-it note. We could say, we could double click it to get into it. It actually tells you double click to edit the panel. So if we double click it, we could say, hey, I was working till 4 a.m. This is what this does. Have a good time with it. Make it beautiful. Okay, so it could just be an annotation. We can just say, this is what this part is, this is what this definition is doing, etc. Good for when you're sharing the definition, working with other people, so people know what's going on. Okay. It can also serve to write numbers. So I could write 30 in here, say OK, and connect this 30 to U. And I'll connect it also to V. Okay. Now make this connection. Does anybody get a red component that looks like this? Raise your hand if you got something like this. You got something like this? What's this? Exactly. So if you got something like this, let me explain why it is that you got it. And this is something I do probably 10 times a week still, even though I've used Grasshopper for many years. The problem is that if we're using a panel to introduce numerical values, okay, a panel is usually set up to have text, to have characters, things that are text-based, okay? Of course, numbers are characters, but what I did here, and it's something that is just ingrained into us by using computers, is after we input some information, we usually press enter, okay? And we don't need to press enter here. What we actually need to do is press OK. So if you notice here, my cursor is below 30, okay? This forces the output of this to read kind of like a paragraph. Okay, you have 30 and then some other text or some space. So the component reads it as some text. And actually the error that we get, it says data conversion failed from string to integer. String is the programmatic equivalent of what we're calling text, okay? It's the data type for text, string. So it says, hey, you've given me some text here. I don't know, I need a number. I don't know what to do with text, okay? And that's because we wrote this number and we're used to pressing enter after we input something. So if you're going to use a panel with numbers, ensure that your cursor is here, that there's no extra information. You can press OK, and then the component can easily read it as a number. Okay, so just make sure you go in here, make sure there's no other spaces, and that your cursor is next to 30, and press OK. And it should fix this error. It's something that, yeah, eventually it's our use of the internet and computers that makes us do this. But quickly you'll kind of grow out of this. Okay, so that's one way. We could get in here, write 50, and it will already sort of update. A plus is that obviously we have the text out here, so we see what we have in UNV without having to hover over that value, okay? So that is one way. Another way, and both of these, let's say, components are quite special. They're very different from the other components we've seen. You know, they don't have this kind of input, although we can input information into it. Anything that takes a strange form that departs from this kind of input-output paradigm is going to be found here in params, inputs, and utilities. These are just weird components that are just take a different form from what we're usually used to. Okay? But here we have another strange mutant, which is the number slider. And the number slider is quite handy as well for this kind of stuff. Let's say that you don't know if you want 50 or 100 or 70 of these things, but you want to play around and try different options. Okay, well, this is what the number slider is helping us do. So I'm going to bring the number slider down here. Okay, and we get this little dot that if we click, we can drag and move it around. Cool, but not so cool. The default is to drag around between 0 and 1. And right now, we're needing integers. This is a real number, okay, with some 3 digits of position. And if we connect this here, we're going to get, you know, it's going to round this to 1, and we're going to get something very strange. Okay, so what I need to do is I need to edit the range of my slider. Okay, so I'm going to double click on the slider, and it's going to give us a little window that we can use to edit its properties. And here we have, most importantly, the numeric domain. What's the minimum of the slider, and what's the maximum of the slider going to be? Okay, so I can double click in minimum and say, I know that I don't want any less than 10 of these frames in a certain dimension. Okay, so I'm going to double click and click 10 and say OK. And I want to say, well, I don't want to go beyond 100. 100 is going to be too much, but maybe I'm just curious to see what happens if I have 100 elements in each dimension. So I'm going to say 100 and click OK. Okay. Now it's going to let us choose the default value eventually, but you know, here I'm working with integers. I'm not working with real numbers. Okay, if I connect this to the input, it's not going to give me an error. It's eventually just going to round up or down to the nearest integer. Okay, so instead of that, I'm going to go over here to rounding and switch it to n, integer numbers. Now it's just forced to give me the integer. Okay, it's not going to do any rounding. I just have whole numbers. Yeah. So I'm going to say OK, and here's my slider. I can just easily do as many of these divisions as my heart desires. If you want a different number in UNV, well, disconnect another slider without shift, just replace the V, and now we have 2-dimensional control over the density of these instruction planes, okay? And to finish this introduction off, well, let's do something besides just generate these instruction planes, because they're not so, they're useful, but they're not, you know, generating any geometry. So I'm going to go over here, and let's say that I want to generate, I don't know, a cone or something that's oriented to this instruction plane. I'm going to go to Surface, Primitive, and cone. A cone is made up of 3 inputs. It has a base plane, okay, which are these guys. You have to be careful because frames and planes mean the same thing. He just hasn't chosen one or the other. Okay, so anytime you see plane, it's the same thing as frame. Just kind of something that he hasn't fixed just yet. Okay. All right. So great. I know that. I'll put that here. It's still. It might have generated something, but it might have generated something very small, depending on how big you created your surface. Mine are really tiny. I have some cones here, but they're just like the tiniest cones I can imagine. Okay, so I'm going to change the radius here. Maybe I use my panel and change the radius to 50. And it's made some bigger surfaces, yes, but the length of my cone is also very small, so I'm going to copy this panel. Maybe say that my length is 75. Maybe I make this a little bit more, like 200. So now I have a kind of a spiky thing. A little hard to see from the preview up here, but you should see it pretty clearly. So, very, let's say, elemental introduction to this. I think that we've covered some very important points for the people just joining us here with Grasshopper. We've seen how to read a basic component. We've seen how to make connections. We've seen how to introduce different kinds of geometry, how to reference geometry from Rhino to Grasshopper. We've seen panels and number sliders. And in terms of the interface and the environment, this is almost everything you need to know to start creating things in Grasshopper, okay? Now, of course, the complexity just grows from here. Now, I mean, there's now an infinite ways that we could use this, and we're only limited by how we can imagine these things go together, okay? And this also takes some time to get used to, because, of course, we're here generating things in a slightly different way. But if you think about it, this is really your thought process sort of recorded into a diagram. Okay, we start with some curves, we make a loft, we find some orientation planes on this surface, and we put some geometry on it. Okay, we've just recorded this logic. Yeah? Very good question. Yeah, I should have pointed this out. When we have a solid cable like this, it means we're transmitting one thing, one object, one point, one text, one element, okay, of whatever. We could also have, I'll show you here something, don't worry about doing this at the moment, but we could have put these together into a single stream and gotten a double cable. This means now we're transmitting more than one element, okay, a list of things. Okay. When we see this monster here, it means we're transmitting a list of lists, okay? This I'll talk about more in depth as we go on, but what happens when we create these frames is that for each row, we have a list of construction planes. So actually the data, the way that it's organized is by row. Imagine an Excel spreadsheet you have a row and all of the columns in that row as one sort of list of elements. Okay, this has in a way generated that in the same manner. Okay, this is helpful for several reasons, but it's going to take several tutorials to really get to be able to exploit this functionality. Okay, eventually, let's say that you only wanted to operate on one row of these things. If you had them as a list, all of them together, it would be difficult to sort of grab them and just focus on one, let's say, row of these elements. That's the reason that this is organized then by rows, because I could change the number of subdivisions. And let's say you had already singled out a row you were trying to work on. Now I change the subdivision. That row might be now something else. It's hard to get into exactly why that's important at this stage of the game. We'll go through several other examples that'll tease out how to start to work then with the data organization that Grasshopper generates. Okay, this is to introduce the interface and how to work with that. Next, and almost the other half of the important part of Grasshopper is going to be in this area called sets, which is all about data management, and this is really important. Yeah. And not a what? No. If you want to bake, well, in this case, you would have to Boolean union them for them to become a solid, or you could group them. They're still individuals, but they can be selected as one object. And yeah, if you bake on the individual here, right-click and say bake, you have the option to group. So then when you bake it, you say OK, and over here in our Grasshopper definition, oops, they're grouped together. Yeah. All right, guys. So for people just starting with Grasshopper, what do you think? Is it too early to tell? Still don't know why we're moving in this direction? We're not going to make spiky things. I can assure you, maybe it's your prototype might want to be spiky, to be hydrophobic for some reason or another. But this is just an example of more to show you the components, how to get them there, how to connect them together, how to bake. So some of the basic concepts of Grasshopper, but it doesn't mean all we can do is make spiky things. We can make much more, many more things. Any questions about this at this moment? Any questions from Mumbai? You guys have been quiet. I don't know if you're still with us or where you are, but I hope you're with us. I'm sorry? The baking didn't work. Okay, let's see what's happening here.